When we talk about exo and endothermic chemical reactions, we often talk about the term enthalpy. Well, what is enthalpy? Well, enthalpy is the amount of energy that is released or absorbed during a chemical reaction. The symbol for enthalpy is delta H. And the reason why it's delta H is we can actually only measure changes in the amount of energy. We can't measure the total amount of energy contained within the reactants and products themselves. We can just measure how that changes. And the unit for enthalpy is usually kilojoules per mole. We can represent the enthalpy of a reaction in several different ways. So first let's look at an exothermic reaction. And we'll look at the formation of water. The amount of energy released when 2 moles of hydrogen, 1 mole of oxygen react to give 2 moles of water is 285.8 kilojoules per mole. So the first way we can represent this in an exothermic reaction is our energy that's released is a product. So energy comes out of this reaction. The other way we can write this is we'll write the reaction in the same way. But instead of making that energy part of the equation as a product, we'll write it at the end. Delta H equals negative 285.8 kilojoules per mole. The reason why this is negative is to tell us energy is being released. Remember, negative Q means energy is being lost or released. Same thing here. A negative delta H means it's exothermic. Energy is being released. Now let's look at an endothermic reaction. So we'll look now at the decomposition of water. In this case, notice I've just flipped my reaction around. And now delta H equals positive 285.8 kilojoules per mole. So when we do a reverse reaction, notice that the energy is the same, the value is the same, but we have the opposite sign. Now this is endothermic, so it's positive. It absorbs 285.8 kilojoules per mole. The other way we can write this is as a reactant. So if we put in 285.8 kilojoules per mole as a reactant, it's endothermic, the energy is being absorbed, and we get our products. It shouldn't be too surprising that these numbers are just opposite in sign if we look at the energy diagrams. If we look at our exothermic graph, you'll notice that if the forward reaction is exothermic, but if instead we start on this side and move to the left, that would be endothermic. So going right to left, exothermic, the products have less energy, but if we go right to left, the products, what used to be the reactants, have more energy, and this distance, the energy difference between the reactants or products, stays the exact same. Let's say I start with 35 grams of hydrogen. How much energy will be released from making that much water from that hydrogen? Well, I'm going to solve this problem just like I solve any other conversion problem. I take my given, 35 grams of hydrogen, put it over 1 times grams of hydrogen on the bottom so it cancels, convert to moles, one more fraction, and then the difference is now I can convert moles of hydrogen to kilojoules. Well, how does that work? We've talked about how these numbers in front represent a mole ratio, but now that we have a delta H, we also know that 2 moles of hydrogen, when it reacts to form 1 mole of water, gives us 285 kilojoules. And this is exothermic, so that should be negative. So we can use that ratio. So the mole ratio, we know 2.02 grams in 1 mole of hydrogen, and we know that 2 moles of hydrogen release negative 285.8 kilojoules. So we use this enthalpy value just like a coefficient for a molecule, except now the unit is kilojoules instead of moles. And we can compare it to moles of whatever compound's in there. And when we solve this, we get 4,952 kilojoules. So when 35 grams of hydrogen react to make water, we end up with 4,952 kilojoules of energy that are released. And this negative sign, remember, tells us that this energy is being given off by the reaction and not absorbed.